Okay, here we've got a volleyball with an incoming velocity of 40 meters per second, and I've taken the liberty of drawing a little sketch. The volleyball's mass is 0.35 kilograms, and let's say it's moving to the right at 40 meters per second. That's my initial velocity of the volleyball. Now this pathetic diagram that I've drawn here, this little stick man, is our volleyball player. The volleyball is going to travel to the right, and this player is going to exert a force on the ball and drive the ball back to the left. So the ball will change a direction and end up moving off with a final velocity to the left of 21 meters per second. And if we know the mass of the ball and the initial and the final velocity, we want to know what impulse the player applies to the ball. Now remember, impulse is a result of a force that acts over a time. And if you apply a force for a certain duration of time, according to Newton's second law, that impulse will generate a change in momentum. So there's kind of two equations there. Now we don't know force or time, so I'm not going to use this first one. I'm going to focus on the second one. Impulse is change in momentum. Now momentum is mass times velocity, so change in momentum will be mass times change in velocity. So that's what we need to focus on. Now remember, velocities are vector in this equation. We have to watch the signs. So let's calculate it. The mass of that ball is 0.35 kilograms. And change in anything is always final minus initial. So I'm just going to write the equation there for now, but watch the signs. So now we'll keep going. 0.35 kilograms. V final is 21 to the left, so I have to make sure it's negative 21 meters per second because it's to the left, minus V initial is positive 40. So notice that's a change in velocity of negative 61. If you simply just subtracted those two, you'd say your change in velocity was 19. That would be the impulse required to slow the ball down to 19 meters per second, sorry, to 21 meters per second, and not change its direction. Here we're doing something more vigorous. We're actually slowing it down to 0 and smashing it back in the other direction so that it ends up going 21 meters per second in the opposite way. So that's why we need to watch the signs. The change in velocity is 61. It is not 19. So when we work all that out, we end up getting negative 21.35, and the units are kilograms times meters per second, which is equivalent, and I'm just going to use significant figures here. It's equivalent to negative 21 newtons times seconds. Those are equivalent units. Kilogram meters per second or newtons times seconds. Force times time, newton seconds, or change momentum, kilogram meters per second. So the negative here just means it's away from the player, to the left. Now that's the impulse applied to the ball, which makes sense. If the impulse is a result of a force, it makes sense that the impulse has to act to the left to change that ball's direction. So there's your impulse acting on the ball. And just as an interesting note, the player would also receive an impulse on their hand, and it would be equal and opposite, according to Newton's third law, something to keep in mind. So the impulse acting on the player would be the same value, just in the opposite direction, Newton's third law.